Next up, we have Iondrive. Iondrive, trading under the ASX code ION, with a market capitalization of approximately $9 million, is an emerging leader in battery recycling technology. The company's primary focus is on developing and commercializing innovative solutions for lithium battery recycling. Presenting for the company today, we have CEO Ebbe Dommisse. Ebbe, welcome, and please take it away.
Thanks, Peter, and thanks for the opportunity. So what I'd like to cover off in today's talk is just 4 areas, just to give some background on Iondrive, articulate the market opportunity for Iondrive, and then talk about the technology itself, trying to dumb it down that people can understand what it is that we're doing. And then finally, just taking the audience through the commercialization pathway. So next slide. Next slide. So Iondrive is a microcap ASX listed company with about 700 million shares on offer. And we can be viewed as a technology commercialization company specializing in battery technologies, where we've got a strategic partnership agreement with the University of Adelaide that enables us exclusive rights on a first rights of refusal basis for any new IP that is not developed. So we're sitting with about 170 researchers that can be viewed as our IP engine, and we are the commercialization arm, and we're focusing on battery recycling. So next slide, please. So the leadership team, we're blessed with a very competent board. 2 of the board members worth mentioning is Michael McNeely, who's the chairman, very experienced in deal structuring, which is important for us going forward with our penetration in the European market. And then Jack Hamilton, I think, is very well known in Australia as with Shell Global for 20 years as vice president, then leading Australia's largest capital project for Woodside with the Northwest Shelf gas project. And also taking Calix as chairman from a 50 million market cap to a $1.5 billion market cap, and very instrumental in taking us forward on our pathway. Myself, experienced chemical engineer, taking chemical processes from laboratory through a series of pilot plants, in my last role as COO of Serco Group, to design and building of a large-scale plant in France. So this is typical. A copy and paste of what we're doing now with a battery recycling hydrometallurgical process. And then Ray Reach, experienced CFO and company secretary, so on governance, keeping me in check as a rookie CEO on what I can declare to the market and not. And then really instrumental to our European penetration is Amrish or Jeff Rito, interesting guy that sits on a number of think tanks in Europe to secure critical minerals in the supply chain for Europe. Next slide, please. So to understand the battery market, here's a slide that shows how battery recycling is increasing from 2030 onwards, when electric vehicle batteries start coming on market as end-of-life batteries. And next slide. And the driving forces for both Europe and America is to really carve out sovereign energy transition capabilities, where we've got a situation where China is sitting with 80% market share for electric vehicle manufacturing as well as battery manufacturing. So Europe and the USA are going about it in very different ways, carrot and stick situation, if you want, where Europe is enforcing legislation to retain battery manufacturing within Europe and also the recycling of batteries. So currently all the recycled batteries are sent back to China for processing. And the USA is doing it with Joe Biden's Inflation Reduction Act, where a significant amount of money, billions of dollars, are spent on creating these capabilities. 2 battery recycling companies that are noteworthy are Redwood and Ascend Elements. Both of them recently did capital raises of about $1.5 billion each. Next slide. So to understand the opportunity in Europe, between 2030 and 2035, there's going to be a CapEx need of about 10 billion euros just to be able to process this end-of-life batteries that are coming on market. Next slide. We engaged a company called Row Motion. So they're a global market research company specializing in battery technologies to really understand the market opportunities globally for battery recycling. And the market opportunity there is enormous. By 2040, we're going to have 11 million tons of black mass. So that's the material that's left over after the battery recycling on market every year. With a market value of $100 billion US. And so the importance of battery recycling is shown in the top right graph, where you can see the deficit of these battery-grade materials if recycling is not done. In other words, the global supply of mining can't keep up with the projected battery demands going forward. And then just the bottom right there is these when these black mass volumes start coming online from 2030 onwards, at a compound annual growth rate of around about 20%. The next slide. Just quickly for the audience, just to explain battery recycling. And I did a talk at my daughter's school a fortnight ago where she said, "Dad, you've really got to dumb this down." And I said, "All right." The batteries are collected and then ground up into black mass. And then there are three major processes. The one is pyrometallurgy. That's where you effectively burn everything and you're left with the metals as a molten alloy. The second technology is conventional hydrometallurgy, where you dissolve everything. And what I explained to the kids is it's like in a crime movie where you take the body and you dump it in a bath of sulfuric acid, you dissolve everything, and then you change the pH and you precipitate out the metal salts. Our process is very different in that we use organic solvents in a closed loop process. And that's like the analogy is like a tea bag that you put in water and you extract the tea out. You then put the tea bag in another solvent like ethanol and you dissolve the tannins out. And so you sequentially remove or extract all the metals that you want. And then you produce battery grade materials from it. The next slide. So the Iondrive's technology is very different from other processes. So it is in a closed loop process using these benign organic solvents. So the advantages of that are a much smaller environmental footprint, where you don't have the same energy usage, much less waste. And if we go into the next slide. Just in terms of our business model to explain where we fit into what the Germans that we're working with call the value circle. So we will receive the black mass and pre-treat that. Then we do the metals extraction from the black mass. And then finally, as we produce PCAM or precursor active materials that then go into the battery manufacturing. So we take up 3 seats at the table. And you can see that the dollar value valorization from $2,000 all the way up to $20,000 a ton. Next slide. So we're following a typical or a conventional commercialization pathway where the technology was developed in the land. We did large-scale bench trials, and we're now busy with a pre-feasibility study before we go into the pilot plant scale. And what's different about our approach is that the commercialization is not just limited to the technology development, but also the market development. So establishing strategic partnerships, establishing suppliers and customers. And in many respects, these market development activities are running way ahead of the technology development, which for me is a first of a kind, where in my previous ventures, we're always working on innovations that were a solution looking for a problem. And this is the reverse, where there's a massive problem in Europe, as illustrated by that earlier slide, that needs a solution. Next slide. Also worth mentioning with this pre-feasibility study is that there's enormous amount of de-risking activities taking place on the technology side. So that scale up, we're busy with engineering work to do the process and design of a commercial scale plant. We'll be doing the cost estimation, both the CapEx and the OpEx. On the commercial de-risking, I've mentioned the low motion market study that really made us understand the supply side of battery recycling, which is critical to secure feedstock for the business case, as well as understanding the demand side, so who the potential customers are, and then also the competitive landscape. So this was also a newbie for me, where we had the funding to do a proper market research study to really understand this landscape very well. And part of that commercial de-risking is also a benchmarking exercise where we compare our CapEx and OpEx and our costs against a conventional process to really understand the competitiveness. And then instrumental to all of this is the strategic partnerships that we've now developed. So that penetration in Europe that I've spoken about, and we'll talk more in the next slides. Next slide. So we've done large-scale bench trials to really show that the chemistry scales, and the significance for investors of this is that it now becomes an engineering challenge to make it work at scale, and then also that a third party independently verified our results, which is really important for us to stand hand on heart that the technology works. Next slide, which will be the next stage is the pilot plant, and then next slide. These industry partnerships, so there was a recent announcement out to market that we formed a collaboration agreement with PEM in Germany. So that invites us to a consortium of industry players, and that really secures our foothold in Europe. And then the very last slide, the next slide, is just this is something that PEM has published, which is of relevance. So firstly, on that left table there, the top reason for startups failure is no market. So we're the reverse of that. And then we're ticking all the boxes on the right-hand side to de-risk these investments. The only one that we're still working on is market competitiveness with these benchmarking exercises. So I know it's been a bit of a mouthful, but I hope that gives you an overview of the market opportunity, the technology that's very exciting, and the people that's working on this and the execution.
Thank you so much, Ebbe. So we do have some questions come through. The first relates, and you just touched on it at the end of your presentation there, but the first question relates to your collaboration to commercialize battery recycling in the EU. Can you please elaborate on the significance of this news?
Yeah, so PEM University is the premier technical university, the largest technical university in Germany. And they work closely with Fraunhofer Institute in Germany, who's famous for putting together consortia solving industrial problems. So we've been invited into this consortium looking after battery recycling in Germany. So it really is a feather in the cap for a small Australian company with standout in technology to be invited to this consortium and establish a battery recycling industry for Germany and wider Europe is that anticipation or that aspiration. So yeah, it's a great development for us.
And I understand that it's not binding at the moment, but are there plans to make it binding moving forward?
Yeah, so our next stage after this, signing the collaboration agreement is also executing on a project agreement where industry players are invited. They sign all the individual project agreements. And I'll be over in Germany in September to formalize the consortium and get the project going.
Clearly, the EU and the US value recycled critical minerals, but does this propose funding opportunities for ION?
I didn't get the question.
So the question is just in relation to funding. Obviously, the EU and the US value recycled critical minerals. I just want to know if there's funding opportunities currently for ION.
Yeah, so Peter, there's an enormous amount of funding opportunities in Europe through government grants, either European-wide government grants or in the case of Germany and the Netherlands, respectively, where we're establishing a foothold. So there's an abundance of grants, but also much interest from private investors for investing into this opportunity.
And lastly, can you provide a rough timeline as to when ION is expecting to commercialize operations?
So we aim to complete the pre-feasibility study in October and then start with the pilot plant, which will probably be a 2.5 year project. before we go into the next stage, which will be a commercial demonstration scale plant. So we're comfortable that we will be commercially operable from 2030 onwards, which is very good timing when these end-of-life batteries start coming on market.
Ebbe, thank you. That's yeah, thank you so much. We look forward to seeing you in the next 6 to 12 months.
Great. Thanks for the opportunity, Peter.